This lesson is about exponents laws of multiplying and also power to a power. So let's go in presentation mode. All right, it's not that I'm so smart, it's just that I stay with problems longer. Who said that is Albert Einstein. One of the people you would, if you had to list who was one of the smartest people in history, you might list him, but he says himself, it's not that he's smarter, he just keeps trying. Okay, this is a way to explain what we are doing. 2 to the third power times 2 to the fifth power, you can see that expanded out here, right? And then how do we write that as a simplified form? 1, 2, 3, 4, 5, 6, 7, 8. 2 to the eighth. So you can see that if you continue to do this, you expand this out, and you expand this one out, and you expand this one out. Really, what are you doing with the exponents over here? 5 and 2. You're adding them up, 3 and 5 to get 8, 1 and 6 to get 7, 4 and 3 to get 7. That's really what's happening to the exponent. Okay, so let's do this a couple of different ways. One way is to expand it. So that's x times x. That's what that is. And then this part is x times x times x. So 3 x's, right? So altogether, that's x to the 1, 2, 3, 4, 5, fifth. Okay? What you're also doing is this, another way you could do it is keep the base and add the exponents. I like the expanded method. It makes more sense to me, but this is true. This is by going by the rule. Okay, so if I had to expand this out, I would have 4 and then x times x, and then also times a 3, and then 1, 2, 3, 4, 5. When variables are right up next to each other, you can just assume they're multiplied, but if you want, you could put a little dot in between. Those are both accurate ways to show multiplication. Combine what you can. The 4 and the 3. So 4 times 3, that's going to give us 12, right? And then the x's we've got here. 1, 2. I'm kind of belaboring this point by rewriting these so many times. 1, 2, 3, 4, and 5. And I have 1, 2, 3, 4, 5, 6, 7. X to the 7th. You could have also looked at this problem as 4 times 3 is 12. This is another way to look at it. Multiply the coefficients, just like it shows you right here, then add the exponents. 2 plus 5. So that equals 12x to the 7th. Okay, 2 ways to look at the same problem. And you can do a combination of the methods, really. Okay. Okay, so then in class, this is what I would have you do and see if you could get it right. See if you could click on the right answer. So what we're doing is we're multiplying the 2 coefficients. 5 times 6 is 30. X to the 2nd and x to the 4th. We're really, if you show that as an expanded thing, you'd have 2 of them and then 1, 2, 3, 4 of them. So altogether 30x to the 6th. Or you could look at it like this. Here's the other method. 5 times 6, that's 30. Then x to the 2nd plus to the 4th. So x to the 6th. Whatever makes sense to you, do it that way. They're both true. Okay, it's a little more complicated. Just have more variables to deal with. No worries. Still, I'm going to look at the coefficients and multiply them. So 80. Oops. 80. Then how many C's? I've got 2 C's and 3 more C's, so altogether that's 5 C's. Whoa, I just jumped ahead, right? I didn't expand it out. I didn't show C2 plus 3. I think if you understand it, you can just go to the next step. This is 1D, and this is 5 of them. So 1 plus 5 is 6. And so that goes pretty fast. Okay, -4 times 3 is -12. How many A's are there? You got 3 over here and 2 over there, so that's altogether 5. You got 1 B and then 5 more B's. Notice this exponent belongs to the A, it doesn't belong to the B. So 1 and 5, and so B to the 6th. There you go. So I'm adding the exponents when I'm multiplying these two monomials. That's what this is. It's a monomial and a monomial. I multiply the coefficients and I add the exponents of the like terms. I'm going to write that down. So I multiply the coefficients. Oop, I think that should be E before I. And then I add exponents of like variables. Meaning the A's go with the A's, the B's go with the B's, the X's go with the X's, so on and so forth. Okay, one more try. Now I have 3 monomials or 3 terms. Doesn't matter. I'm still going to multiply the coefficients, and then I'm going to combine all of the like variables exponents. So there's a 1 right here for the m's, and then here's 2 more m's. So that's m to the 3rd. Then we have some n's. Here's 1 n and then 4 more n's, so n to the 5th. If you're like, I don't understand, you kind of are jumping ahead here, then okay, let's do it again. Let's do it in a different way. I'll slow down a bit. 6 times 7 is 42, though. I think you can agree with that. Then we've got an m here, and then we've got 2 more m's, and then I've got an n, and then I've got 4 n's. 1, 2, 3, 4. So now I have 42 m to the 1, 2, 3, n to the 1, 2, 3, 4, 5. Bada boom, bada bing. Okay. So we are adding the exponents of our like variables. Okay, just, when you add some fractions in there, people freak out, but it's not that big of a deal. You can do this many different ways. You could do 12 times 2. Think of this as being over 1, right? 12 times 2, 1 times 3, and then divide them. Or you could do 12 times 2, and then divide by 3. You could also see that these are both divisible by 3, so make this into a 1, make this into a 4. Let's do it the way most people would. 12 times 2, that gave us 24, and then divide by 3, and that is going to give us 8. Okay, now how many x's and y's? Well, there's only one x, and then here's a y, and here's 4 more y's, so that's y to the 5th. I'll do this the more expanded way, in case you want to see that. So negative 2 times the 3. Then let's write all the x's. There's one of them, here's another one, and then here's 2 more. Here's a y, and here's 3 more. Negative 6, x to the 1, 2, 3, 4, y to the 1, 2, 3, 4, 5. So we multiply the coefficients and we add the exponents. This has an exponent of 1. This has an exponent of 1. This has an exponent of 1. All of these have exponents of 1, right? So we're just adding those ones up, and that's how I'm getting this number. You could think of this as having exponents of 1, and that has an exponent of 2, right? And this has an exponent of 3. So you could think of it this way. I'm doing it again in another fashion here. Negative 6, and then x to the 1 plus 1 plus 2. And the y to the 1 plus 1 plus 3. So negative x to the 2, 3, 4. Y to the 3, 4, 5. Okay, however you want to get your answer. Those are all valid ways. Okay. This is actually one big problem And I want you to think about order of operations, PEMDAS, right? Before I do addition and subtraction, okay, which is what that symbol is addition, I have to do this, multiplication or division. So I'm going to deal with these terms, and I'm going to deal with these terms, and then I can do some addition. Maybe, if they all have the same variables to the same power. You'll see what I mean. 4 times 5 is 20. A to the third plus 1 is a to the fourth. B to the fourth and b to the second. Okay, then plus, what do we have over here? I have a 1, basically, and a -2. So -2. A to the, there's 2, 3, 4. And then b to the fifth and one more, b to the sixth. Okay, now's the time. You look at, are these the same variables to the same powers? Exactly. It has to be exact replicas of each other, okay? Then I can go ahead and do some more math. I can add, but I'm adding a negative. So really what I'm doing is 20a to the fourth, b to the sixth, minus 2 a to the fourth, b to the sixth. So if I have 20 of them, minus 2 of them, that's 18 of them. And what are They are these. They are A4, B6s. Okay? Okay, that's okay. We're going to stop here.